Okay, we need to check the continuity at x is equal to 1 and x is equal to 2. First of all, we will define this modulus, mod x minus 1. Anyone can tell me how can we define this modulus?
X minus 1 if x greater than or equal to 0 and 1 minus x if x is less than 0.
Okay, please check here. Yesterday we have discussed about this mod x. Why we were saying that greater than equal to 0? Because if you will compare the expression which is inside this modulus, that is x. If you will compare this with 0, then you will get a 0. That's why we were comparing this with 0. In this case, in this question, we have a x minus 1. Okay, so if we will equate this x minus 1 with 0, then we will get the point 1. So always please remember this point, how you will get whatever the expression you have inside the modulus, always equate that with 0 and you will get a point. Okay, Atif. So here we will say greater than equal to 1 and x is less than 1. Is it clear? Atif, Huzefa, and Noma?
Yes, sir.
Okay, good. Atif?
Yes.
Okay, Huzefa, you were absent yesterday. Did you check the recorded lectures? Okay. So when x is greater than equal to 1, this will be positive, x minus 1. And when this is less than 1, then we have negative x minus 1. Okay. I hope this is clear to all of you. Now, who can tell me this? Noma. Noma, please define this modulus. Noma, please define this modulus as we have defined this modulus x minus 1. No?
X minus 2 is greater than equal to 1.
No, why 1? Greater than equal to 2.
2.
Okay.
And minus of x minus 2.
Very, very good. Very good. Now, separately, we have defined these two modulus, but in the question now, we have to add these two modulus. Okay. How can we define this? How can we define this one? We will take this one, x is less than 1. First of all, we will take this, x is less than 1. Okay. X is less than 1. Okay, Darshan. Darshan, yesterday also you had some issues, so please check the recorded lectures of yesterday class. Okay. Now, x is less than 1. Okay, so Darshan, I will again explain this to you. We have in this question x minus 1 plus x minus 2. Nabil, did you try to solve this question? Nabil, did you try to solve this question?
Yes, sir.
Okay, is it done?
Yes, sir. I found for x is equal to 1, limit does not exist.
Okay.
X is equal to 2, I couldn't find, sir.
Okay, we will check this. So please, all of you again check here. We have a modulus x minus 1. Okay, yesterday we have checked modulus of x. So modulus of x is what? X when x is greater than equal to 0. And it is minus x when x is less than 0. So whatever the expression you have inside the modulus, you will equate that with 0. And whatever the point you will get, you will take that point as a reference point. So here in the modulus, we have x minus 1. So we will put this x minus 1 to 0. We get a 1. So we get a reference point 1 here. So here we will check the 1. Similarly, so when x is greater than equal to 1, this is x minus 1. When x is less than 1, then it is negative minus x minus 1. Similarly, for this one, x is x modulus of x minus 2. So we will get the reference point as 2. So x is greater than equal to 2, it is x minus 2. X is less than 2, it is minus x minus 2. Hope this is clear to everyone. Okay, now when x is less than 1, who can tell me? Nabil. Nabil, can you tell me when x is less than 1? And what about this first function, x minus 1? This will be what? Positive or negative?
It will be negative, sir.
It will be negative. Very good. Minus x minus 1. What about the next? X minus 2?
Will also be negative.
This will also be negative. Very good. So all of you, please check here. I hope this is clear to you. Why the second modulus is negative? We have x is less than 1. If we will check this case, when x is less than 2, then it is negative. When x is less than 2, it is negative. If x is even less than 1, then what will happen? If a number is less than 1, then definitely it will be less than 2. Okay, that's why we will put this x minus 2 as negative. Now solve this. What you will get? I will write here minus x plus 1 minus x plus 2. So minus 2x is equal to minus 2x plus 3.
Sir, we're supposed to evaluate the modulus separately, sir, for the two functions.
No, we actually, you need to show only a single part. Okay, but I've explained this two separately so that you will not have any confusion in the question. Okay, once I will complete
Okay,
this,
sir.
I will
Okay.
erase this. There's no need in the exam to show this part. Okay, now
Yes.
x is less than 1. Next, we will check x is greater than 1, greater than equal to 1. Okay, if x is greater than equal to 1, then who can tell me next? Darshan. Darshan, can you tell me about the first function? If x is greater than equal to 1, then what about the first? It will be negative or positive? I guess, Darshan, you still have some network issue. Then who can tell me? Yes, Darshan, I was saying when we are taking this x is greater than equal to 1, this one. When we are taking x greater than equal to 1, then what about this function? What happened with this? This will be positive or negative? Darshan, please let me know if it is not clear. No reply. Huzaifa, can you tell me when x is greater than equal to 1? Then what about this x minus 1? It will be positive or negative? Okay, my voice is not clear. No issue, Darshan. Actually, you have some network issue. Okay. Positive. Very good, Huzaifa. So when x is greater than equal to 1, then this first part will be positive, x minus 1. Huzaifa, can you tell me about the second part, x minus 2? This will be positive or negative? Huzaifa, what about the second part, x minus 2? It will be positive or negative? It can be both. Yeah, that's correct. Okay. So when x is greater than 1, then this can be both. X is greater than 1 and less than 2, then we have a different condition. And if this greater than 1 is even greater than 2 also, then we have a different condition. So what we will do, we will break this. We will take here two conditions, that x is greater than equal to 1 and less than 2. And third, we will take this condition, x is greater than equal to 2. Okay. Now for this one, Huzaifa, can you tell me the second part, x minus 2, it is positive or negative? Huzaifa, this one, modulus x minus 2, this will be positive or negative? This will be positive? Not sure. Noma, can you tell me modulus x minus 2, this will be positive or negative?
Negative.
Negative. Okay. Please check here. That's why I've written this one. For x is less than 2, this is negative. So we will put a negative here. X minus 2. Now open the bracket, solve it. What you will get, x minus 1 minus x plus 2, x cancel out. So you will get a 1. Here you get a 1. Next is x is greater than equal to 2. Okay. Who can tell me this? Atif. Atif, x is greater than equal to 2. What about the first part? It is positive or negative?
Positive.
It is positive. Good. So x minus 1. What about the next, Atif?
Positive.
Positive, very good. Okay, so finally what we get here? 2x minus 3. So we get three conditions. X is less than 1, this function, greater than equal to 1, less than 2, this function, greater than equal to 2. We have this function, okay? So there's no need to show this. If you understood this, you can do this directly. If you have a doubt in exam, then you can do this in the rough page, okay? And directly write the answer like I've shown here, okay? Now we need to check the continuity. We need to check the continuity at x is equal to 1 and x is equal to 2. Okay. So as you have an inequality, so please use the LHL and RHL concept. First check for 1 and let me know this is continuous at x is equal to 1 or not. Then check for 2. Okay. Please do this and share your answer. If anyone have a doubt, then please let me.
So can you just please say how we got those values in the right step?
Which one? First, second, or third?
Like all of them, so like how you took the mod and expanded.
Uh,
Because when I did in homework, I just took both of them directly, like both mod of x1, mod x2, I took directly. Like, that is
how directly, Nabil? For example, can you tell me what you have done here?
I took like this f of x I is equal to either two. Uh, First one is x plus 1 plus x minus 2 is equal to 2x minus 1 when x is greater than or equal to 0. And
Oh,
other
okay,
option
okay, okay, understood, understood. So you have taken x is greater than equal to 0, and I
is,
guess second x is less than 0.
yes, sir.
Okay, okay, this is the mistake. Always remember when we discuss about the modulus, why we have taken 0, because the expression which is inside this modulus is x. So whatever the expression you have inside this modulus, always equate that with 0 so that you will get a reference point. So for this one, the reference point is 0. That's why we have taken x is greater than equal to 0. X is less than 0. Okay. Now we will separately, first of all, analyze these mods. Continuous at 1 and discontinuous at 2. Okay. Let me check, Noma. Noma, first is correct. X is equal to 1. It is fine. Please check for 2. Okay, again check for 2. Now, Nabil, we have this modulus x minus 1. Okay, so if we need the reference point here, then we will equate the expression which is inside the modulus with 0. So we will get the 1. So here the reference point will not be 0. The reference point will be 1. Okay, this is the mistake which you have done in your question. So how you will get that reference point? Always equate whatever is there in the mod with 0. So here we get a 1. So x is greater than 1, less than 1. Okay. So for greater than 1, it will be x minus 1. And for less than 1, it will be minus x minus 1. This is clear,
Sir.
Nabil?
Yes, sir.
Okay. Now, similarly for modulus of x minus 2, what will be the reference point?
2, sir.
Greater than equal to 2 and x is less than 2. So this we will get x minus 2, this we will get minus x minus 2. Okay. Now, but in the question, they have combined the two modulus. So what we will do, we will combine all these conditions. Okay, so the lowest is x is less than 1. That's why we have taken with this. When we have mentioned x is greater than equal to 1, then we can't decide the second part because the number is greater than good, Atif, it is correct. If the number is greater than 1 but less than 2, then it will be negative. And if it is greater than 2, it will be positive. So what we need to do, we will take a reference 2 also at this point. So x should be greater than equal to 1 but less than 2. So first will be positive, second negative, and for the third one we have taken x is greater than equal to 2. Is it clear, Nabil?
Yes, sir.
Okay, Darshan, is it clear? Darshan, this concept is clear?
Sir, why we don't take equality in the first case, sir? X is smaller than or equal to 1, why don't we take?
Sorry. Yes, Nabil, what's your question? Okay, Darshan, good. Yes, Nabil, what is your question? Nabil, please message me, okay? Your voice is not audible. So,
Sir, why don't we take in the first equation, we got minus 2x plus 3. Why don't we take the condition as x is equal to or less than 1?
so you're saying that here why we are not taking as x is less than and equal to 1.
Yes, sir. Because in the last one, we have taken x is less than or equal to 2.
Where we have taken x is less than equal to 2.
And 2x minus 3, sir. In that last equation.
No, we have taken x is greater than equal to 2.
Yes, sir.
Okay. So always take equal to with the greater sign. Okay, so Atif
Okay.
has completed this. Noma has done. Darshan, will you please complete this? Yesterday we have done the continuity. So use the same method here and proof it. Okay. Therefore, is it done? Josefa and Darshan, please confirm me once it is done. Okay, Nabil. Now please complete this question and confirm me. And if anyone still have a doubt, then please let me know. Nabil Khan, you are half an hour late. What is the reason? Nabil, why you are half an hour late? Network issue. Okay, no worries. Nabil, you missed something, so please check the recorded lectures for that. Okay. And Nabil Ahmed,
Yes, sir.
is it done?
I'm nearly done, sir.
Okay, okay. Darshan and Josefa, is it done? Okay, Josefa, very good. Darshan, is it done? Darshan, is it done or you have a doubt in this? Okay, okay. Darshan, yes means it is done. Darshan, you have completed this? Oh, okay, Darshan, very good. So we will start next question. Nabil Ahmed,
Yes,
please
sir.
confirm once it is done. Okay. So now the next question is determine the value of k for which the following function is continuous at x is equal to 3. Okay. You need to find the value of k and it is given that the function is continuous. So who can tell me the condition for continuity? Noma. Noma, what is the condition? When we will say that the function is continuous and limit extends to a f(x) is equal to
F of A.
f of a. Very good. Now, please check here. First of all, we will find out f3 because we need to check the continuity at 3. So f3 is equal to, it is given here, f3 is equal to k. Next, we will find out the limit. Limit extends to k f(x). Who can tell me? Darshan. Darshan, can you tell me that which function we will choose when we are finding the limit? First or second function? This is first and this is second. So Darshan, which function we will use? Great, Atif, it is correct. Darshan, which function? First or second? Darshan, which function we will choose if we need to calculate this limit? Which function? Oh, okay, okay. I'm saying that we have to find the limits here. Okay. So can you tell me which function we will choose? Which function we will choose if we need to find this limit? Second, okay. Noma, can you tell me which function we will choose? First one. Okay, so Darshan, this we have discussed yesterday that if we need to find the limits, then that means, sorry, why I am writing this k? This should be 3. X is approaching to the value 3. Okay, x is not equal to 3. X is approaching the value 3. X is not equal to 3. So when this, okay, Josefa. Okay. Okay, so x approaches to 3. So that's why we will take the second function. Always remember this. X is not equal to 3. X is going towards to 3. That's why, Darshan, we will take the first function. Please remember this because here we have x is x not equal to 3. Now this is equal to limit x tends to 3. Okay, we will solve this. If we will put this limit directly, we will get a 0 by 0. Please check here. 9 minus 9, 0. 3 minus 3 is also 0. So what we will do, we will factorize it. Okay, how can we factorize it? We will write x square minus 3 square by x minus 3. And this is equal to limit x tends to 3. This is x minus 3, x plus 3 by x minus 3. This part cancel out. Limit x tends to 3 and this is x plus 3. This is equal to 3 plus 3, which is 6. Noma, standard method, which one? X to the power n minus a to the power n? Yes,
Yes, sir.
yes, you can use that method also. So we get this limit. Now it is saying that the function is continuous. Fx is continuous. Okay, it is given here. Fx is continuous at x is equal to 3. Hence, limit x tends to 3, fx is equal to k. Now what is this? This is 6. 6 is equal to k. So we can say k is equal to 6. Okay. I hope this is clear to everyone. Now please complete this and raise your hands so that we can start the next question. Okay, Atif has already done this. So all of you, please note down this and raise your hands. Okay, Nabil, very good. Okay, Noma, very good. Darshan and Nabil Khan, please confirm if once it is done. Okay, Nabil, very good. Darshan, please confirm once it is done. Okay, Darshan, very good. Now we will check the next question. Okay, this is also a very good question. Find the value of the constant lambda. Okay, find the value of this lambda so that the function given below is continuous at x is equal to -1. So this function is continuous. Please find the value of lambda. Okay, please complete it and share your answer. Everyone, please let me know if you have a doubt in this. Atif, very good. It is correct.
So lambda is equal to 0, sir.
Sorry, Nabil, it is not correct. Please check your answer. Nabil, what is the value of limit? 0. No, that's
Yes,
not
sir.
correct. No, that's not correct.
Sir, is it
Nab-
1 by
no, Nabil, it is not correct. Please again check it.
is it 1?
No, not wrong.
Sir, lambda is equal to -4, sir.
Very good, Nabil. Noma, it is correct. Very good. Darshan and Nabil Khan. Very good, Darshan. It is correct. And Nabil Khan, please check this. Okay. And Darshan, did you get the matrices lectures, the recorded lectures of matrices? Not sure how they shared with you because they were telling me that they have already provided the lectures to you. Okay, let me check with them. I guess everyone has completed this. Nabil Khan, is it done?
No, sir.
No? Okay, okay. I will solve this. So here it is given that the function is continuous. So first of all, we will calculate the limit. Limit x tends to -1 fx. So Nabil, which function we will choose for this limit? Which one, Nabil?
Sir, x equals to -1, right?
Yeah, for x is equal to -1, we have this. For x not equal to -1, we have this. So when we are
So
finding the limit,
we'll use the first one.
we will use the first one. Good. -2x -3 by x plus 1. Okay, so this is equal to limit x tends to -1. And factorize the numerator x square minus 3x plus x minus 3 by x plus 1. So this is equal to limit x tends to 1 minus 1 and take x common. So x minus 3 plus 1. This is x minus 3 by x plus 1. So here we will get limit x tends to -1 and take common x plus 1 into x minus 3 by x plus 1. So cancel out this. So limit x tends to -1, x minus 3. Now put this limit. So -1 minus 3 is equal to -4. Okay, Nabil. It is clear.
Yes, sir.
Okay, then please note down this and confirm me. Okay, so you just need to equate the lambda with -4. So please
Yes,
note.
sir. I factorized it wrong.
Okay. Okay. So please confirm me once it is done so that we can start the next question.
Finished, sir.
Okay, great. Okay, this is a very, very good question. This came in 2002, 2010, 2011, 2012. Okay. You need to find the value of a and b. This function is continuous at x is equal to 1. So all of you, please complete this question. If anyone have a doubt or need a hint, then please let me know. If anyone have a doubt, then please let me know.
Sir, A is equal to 3 and B is equal to 2, sir.
Yes,
A3
I got the
and
same.
okay, Nabil, very good. Okay, Nabil, Ahmed also. Both of you are correct. Okay, Darshan, very good. Darshan, same answer, A3, B2. Okay, okay, very good. So Nabil, Darshan has completed this. Atif and Noma, is it done? Um, no, shall I solve this, Atif?
Sir, we solve the
Okay, you're doing. Okay, Noma, is it done?
No, sir.
Any doubt?
In- Sir, I'm getting A is equal to B by 3B by 2.
Okay, let me solve this. Okay, so here it is given that this function is continuous, that x is equal to 1. So that means limit exists and the value also exists. Here, if you will find f1, it is equal to 11. Good. Now it is given that function is continuous, so limit exists. So that means LHL will be equal to RHL. So first of all, we will calculate LHL at x is equal to 1. Okay, so limit x tends to 1 minus fx, and this is equal to Noma, which function we will choose for 1 minus?
Second one.
Second or third?
So third.
Third. This first, this is second, and this is third. Okay, so we will use the third one, 5ax minus 2b. Put x is equal to 1 minus h. So what you will get here? Limit h tends to 0, because we know that when x approaches to 1 minus h approaches to 0. Here we will get what? 5a, here put 1 minus h minus 2b. Put this limit, so you will get a 5a minus 2b. So this is LHL. Now similarly, please find RHL at x is equal to 1. So RHL at x is equal to 1. So what you will get here? Limit x tends to 1 plus fx. So this is equal to limit x tends to 1 plus fx is what? Fx is, okay, Noma, which function we will use here for RHL?
First.
First one, 3x plus b. 3ax plus b. Let x is equal to 1 plus h. The same thing when x approaches to 1 plus h to 0. So this is equal to limit h tends to 0. Okay, 3a 1 plus h plus b. 3a plus b. Okay, we'll put the limit. We will get this. So this is RHL. Limit exists. Limit exists. Hence, okay, limit exists because it is continuous. Hence, LHL at x is equal to 1 is equal to RHL at x is equal to 1. At x is equal to 1. What is LHL? LHL is 5a minus 2b. 5a minus 2b. What is RHL? It is 3a plus b. Shift this a to the left side. So what you will get here? Okay, but better is to do one thing. We will write that the function is continuous. Function is continuous at x is equal to 1. Okay. Therefore, this implies limit x tends to 1, fx is equal to f1. So that means limit LHL is equal to RHL is equal to f1. What is the value of f1? It is 11. Okay, so we will write here. LHL was 5a minus 2b. 5a minus 2b is equal to RHL is 3a plus b is equal to 11. Okay, so you will get here 5a minus 2b is equal to 11. Second, you will get 3a plus b is equal to 11. Now we will solve these two. So what we can do, we can multiply this equation second with 2. So what we will get here, this is 5a minus 2b is equal to 11. Here we will get 3a plus 2b is equal to 22. So cancel out these two. This you will get 2a is equal to
6a plus b, right?
sorry. 6a plus 2b 22. So here, sorry, this is 11a and this is equal to 33. Okay, so a we will get here 3. You can put this value in any of the equation. Okay, so put a is equal to 3 in this equation. 5a minus 2b. 5a minus 2b is equal to 11. So you will get 5 into 3 minus 2b is equal to 11. So minus 2b is equal to 11 minus 15. So minus 2b is equal to minus 4 and b is equal to 2. So we get these two values. Okay. Noma, is it clear?
Yes, sir.
Okay, then please note down this. Josefa, you have just joined. So we have not started any new topic. Okay. Josefa, please check this question. If the function fx given by is continuous, in this question, it is given that the function is continuous. We have to find the value of a and b. Okay. So f1, if you will find, we will get 11, which is already given here. Okay, Josefa. Now we will calculate the LHL. You know how to calculate the LHL. Similarly, we have to calculate the RHL. Okay. So Zephyr, please note down this first slide. Then I will change the second, and then I will change the slide and explain to you the next one. Okay. Please let me know, Zephyr, once you note down this. Zephyr and Noma, please confirm once it is done. Okay, Zephyr, very, very good. So, okay, Noma, very good. Zephyr, only two questions you missed. Okay. So I will discuss those two questions later on with you. Next, we have calculated the RHL here. Okay, Josefa. So you know how to calculate an RHL. So we get a RHL 3a plus b. Here the function is continuous at x is equal to 1. That's why limit is equal to f1. LHL, so if limit exists, okay, this is not negative. This is not negative. Okay. So if LHL is equal to RHL is equal to f1. So LHL is this, RHL this, and this is equal to f1. So we get the two equation here, Josefa, and we have solved these two equations. Okay. So please note down this, Josefa, and let me know if you have any doubt here and confirm once you complete this slide. Josefa and Numa, please confirm once it is done. Okay, Noma, very good. Josefa, is it done? Okay, great. So last slide. Okay, Josefa. So in the previous slide, we get a is equal to 3. We have just put that value here and we get a value b is equal to 2. Okay. Please note down this and confirm once it is done. Okay, Noma, good. Josefa, is it done? Josefa, is it done? Okay, great. Then we have one more question. This question is you have to do in homework. Okay, this is also a very important question. This came CBSE 2010, then 12, then 13. Even it is there in the NCRT exemplar. Okay, this question is in homework. Please complete this. I will check your homework next week. Okay, this is a very good question, very important one. Please complete this question. Okay. All of you, please raise your hands once you noted down this so that we can start the next question. Okay, all of you, please raise your hands if it is done. Okay, Noma, very good. Everyone, Nabil Ahmed, Atif, Darshan, Huzefa, Nabil Khan, is it done? Shall we move to next?
Yes, sir.
Good, good, Darshan. Okay, Nabil. So is left Huzefa. Huzefa and okay, Nabil Khan. Huzefa, is it done? Shall we move to next? Huzefa, is it done? Huzefa, shall we start the next question? Huzefa, I'm not sure. Okay, good. Now, next topic. Till now, we have checked what is the continuity at a point. Okay, if you will analyze all these questions, and in all these questions, we have checked that the function is continuous or not at a single point, or we have to find the value of a variable if the function is continuous at a single point or not. Okay, but in this topic, we have to check that the function is continuous or not. So what does this mean? A function is said to be continuous if it is continuous at each point of its domain. Okay, I hope everyone know that what is the domain. Suppose we have fx is equal to 1 by x minus 1. Anyone can tell me what is the domain of this function?
All values for x other than 1.
Very good, very good. Okay, so what's the domain? What value of x you can put here so that you will get a real number? What real values can you put in this function so that finally you will get a real number? So you can put all the real number except 1. I guess I already told you that in the denominator we should never have a 0. So we can't put 1 here in the denominator. Okay, so domain is every real number except 1. Now, when we will say that the function is continuous, a function is said to be continuous if it is continuous at each point of its domain. If your function is continuous at each point of its domain, for example, in the previous question, as we have checked that the domain is R except 1. So if this function is continuous at all these values R except 1, then we will say that the function is continuous. Okay, I hope everyone has understood the difference between the previous topic and this topic. In the previous topic, we have checked the continuity at a particular point only. In this topic, we are saying the function to be continuous throughout it is on its domain. Okay. Who can tell me this again? So Darshan, your mic is working. Darshan, your mic is working. Not sure, Darshan. Yeah. Okay, Darshan. Nabil Khan. Nabil Khan, can you tell me the difference between the previous topic and this topic? Darshan, what is the difference between the previous topic and this topic? Oh, Josefa, can you tell me the difference between this topic and the previous one? No? Who can tell me? Atif, can you tell me the difference between this topic and the previous one? Yes, Atif?
Sir, difference between function and continuous function.
No, I'm saying difference between on this topic. Right now, we are discussing about the continuous function, and before that, we have done a topic. So can you tell me what's the difference between this? Previous means continuity at a point. So what's the difference between these two? I'm not
The
sure.
previous topic, we checked if continuous are at only one single point, and this will check at each and every.
Yes. In the previous topic, we have checked that the function is continuous at one point or not. If you will check all the question, for example, any question like this, we are just talking about the continuity at a single point. But in this topic, we have to check that the complete function is continuous or not. So when we will say that the function is continuous, if it is continuous at all
At every
points,
point.
at every point of its domain. Okay. So I hope now the definition is clear to all of you who has left the class. Okay, no one. Okay. Next we have a theorem. If f and g are two continuous function, if we have two function, f and g, these are two continuous function, okay, on their common domain. So both on their common domain means whatever the domain is matching, then first is summation of these two function is also continuous. Just give me a minute. Just kind of leave this. Okay. If f and g are two continuous function on their domain, then f plus g. That means if two functions are continuous, you will add those two functions, then the summation of those two functions will also be continuous. Next one, f minus g is continuous. If you will subtract these two, you will get a continuous function. F into g is also continuous. Okay, if you will multiply those two functions, that will also be continuous. Next is f by g. If you will divide those two functions, that will also be continuous. Remove this part. We are not talking about only a single point. Okay, provided the denominator should not be zero. Provided gx, we will say, provided gx should not be equal to 0. The denominator should not be equal to 0. Okay, so I hope everyone understood this theorem. We will use these theorem in some questions. If you have two functions, then their addition will also be, if you have two functions which are continuous, their addition will also be continuous, their subtraction will be continuous, their multiplication will be continuous, and their division will also be continuous, provided the denominator should not be equal to 0. Okay, so I hope this is clear to everyone. Please note down this, raise your hands, then we will check some questions. Okay, Atif, very good. Okay, Nabil. Okay, Noma. Good. Darshan, Zephyr, Nabil Khan. Please raise your hands once. Okay, Nabil. Very good. Darshan and Huzefa, please raise your hands if it is done. Okay, Josefa. Darshan. Okay, Darshan. Very good. Now next one. Leave this. This we will do later on. Okay. So now we have this question. What we have to show here, if a function f is defined as fx is equal to this, show that f is everywhere continuous except at x is equal to 4. So you need to show that this function is continuous everywhere except at x is equal to 4. Okay. Now please check the steps. First of all, we have a modulus function. So you all know that we will simplify this. So fx is equal to, in the rough, we will check this modulus mod minus x minus 4. Who can tell me this? Atif. Atif, can you tell me how we will define this modulus of x minus 4?
X minus 4 x is greater than or equal to 4
Good.
and minus x minus 4 if x lesser than 4.
Very good. I hope this is clear to everyone. The reference point is 4. So when x is greater than or equal to 4, we will get this value. Less than 4, we will get. But if we will see the question, then it is already saying that for x is equal to 4, they have given this value 0. So we can't use equal to here. Okay, normally we will take equal to, we normally take a equal to, but in this case, for equal to, they have already given a 0. So we can't use this value. So what the value we will use, we will say that x is greater than 4. We will not take equal here because in the question, they have already given a value 0 for x is equal to 4. So we can't take equal. In this case, we will ignore the equal. So here we will get x minus 4 by x minus 4, and this is equal to 1. Okay, next one. X is less than 4. So what the value is? X minus 4 by x minus 4. So this will give you minus 1. Third, x is equal to 0. We already, sorry, x is equal to 4. We already have the value 0. So all of you, please let me know, is this clear?
Yes, sir.
Yes,
Okay.
sir.
Okay, no more good. Nabil, Josefa, is it clear?
Yes, sir.
Okay, okay, Josefa, very good. So we get a 3 value. Now, what is the question? They are saying show that f is everywhere continuous except at x is equal to 4. So we need to check the value at x is equal to 4. Other than that, we have to show that this function is everywhere continuous. Okay, so I hope everyone now understood the difference. So please check the steps. What we will do here in reference book, you can find a different method, but we will use this one. Let k be a real number, and k is greater than 4. Okay, k is less than 4, or k is equal to 4. So we have taken k a real number, and what the value k will take? K can take greater than 4 value, k can take less than 4 value, and k can take 4 value, k is equal to 4. Okay, so in this case, what we will do, please check here, case 1. Case 1. Okay. Here k is for k greater than 4. So for k greater than 4, who can tell me fx is equal to Nabil Khan? Nabil, can you tell me what is fx here for k greater than 4?
Uh,
Okay, Darshan, I will repeat this question. Fx is equal to what? Nabil?
fx minus 4 by first one.
First one. Very good. Because the value is greater than 4, that's why fx is greater than 1. Okay,
Yeah.
so, okay, great. Darshan, we have this question, okay? in this question, we need to show that f is everywhere continuous except at x is equal to 4. So first of all, we have defined this modulus here. You already know how we need to do this. Okay. X is greater than equal to 4. This is equal to x minus 4, less than 4. We will get this. But in this question, it is already given that x is equal to 4, then the value is 0. X is equal to 4, the value is 0. That's why we will not take equality here. We will not take equality because the equality value is already given. That's why I've already taken only x is greater than 4. Okay, then less than 4 and equal to 4. Okay, Darshan. Now we have assumed a number k. Let k be a real number and k is greater than 4, k is less than 4, or k is equal to 4. Now, for k is greater than 4, fx is equal to 1. If we will put fk here, then who can tell me this? Josefa. Josefa, can you tell me if we will put k here, then what the value we will get? Josefa, in place of this x, if you will put k, then what the value we will get? 1. Very good. Because here we do not have any variable. So even if we will put k in place of x, we will get 1 only. Now next one. Next is limit x tends to k fx. Okay. Now the next question is from Noma. Noma, can you tell me that for this one, limit x tends to k, which function we will use? First one. Okay, why first one? Because we have taken k greater than 4. So we will choose the first one. So here we have a 1. If you will put this limit in 1, you will get a 1. So limit x tends to k. Limit x tends to k fx is equal to f1, sorry, fk. Hence, function is continuous. Hence, the function is continuous for all k. Sorry, the function is continuous for all the real number greater than 4. Okay, so here we have proof that limit is equal to fk. That means this function is continuous for k. Now what is k? K is greater than 4. That's why we have written that this given function is continuous for all the real numbers greater than 4. So I hope this is clear to everyone. Okay, so please note down this. There's no need to note down the first one. Okay, leave this. Note down this complete question. Let me know if anyone have a doubt in this one. In the previous questions, they have just given a single point. That's why we have shown that. But in this case, we have to show for the complete interval. Okay, everyone, please raise your hands once you will complete the first slide. Okay, Nabil, very good. All of you, please raise your hands. Okay, Josefa, very good. Rest of you, please do this. All of you, is it done? Is there anyone who is left? Okay, Darshan, very good. So I guess everyone has completed this. Now we will check the next one. If anyone miss anything, then please let me know. Now case 2. Okay. Next value we will take. Here we have taken greater than 4. Next we will take less than 4. Okay. For k less than 4. Okay. So next question, who can tell me? Darshan. Darshan, can you tell me for x is less than 4, which function we will choose? We have 3 functions. 1, 2, and 3. So which one we will choose, Darshan? Second one, very good. For less than 4, we have -1. Okay. For x is less than 4, fx is equal to -1. We will put k. So what we will get here, -1. We will find the limit. Limit extends to k, fx. So for this limit also, we will choose the second function only, which is -1. It will give us -1. So limit x tends to k, fx is equal to f -1. Sorry, f k. Okay. Hence the given function is continuous for all real number less than 4. Okay, so that means this function is continuous for all real number less than 4. So all of you, please note down this, then raise your hands so that we can do the last part, case 3. Okay, Nabil, very good. All of you, please raise your hands if it is done. Okay, Noma, good. Okay, Zafar, very good. Atif, Darshan, Nabil, is it done?
Yes.
Okay, good. Atif, is it done? Atif, is it done? Okay, I hope everyone has completed this. Now we will check for the third one. Case third is k is equal to 4. So now we will check for k is equal to 4. Okay, what the value fx will take? Who can tell me? Yes. Noma. Noma, can you tell me what the value fx will take here for the third part?
0.
0. Okay, it is given that for x is equal to 4, fx is 0. So we will take this one. Always remember when we are doing the continuity, these function will always be continuous. X is greater than 4, this will be continuous. Less than 4, this also will be continuous. Okay, and we have to show in this way. Where there is a possibility that the function will not be continuous, that is at this point, x is equal to 4. Okay, where there is a possibility that the function will not be continuous, that is at that given point where there is a change in the function. Okay, so always remember the function will be continuous for greater than 4, for less than 4, where there is a change in the function. That means these reference point, there is a possibility that the function will not be continuous. Okay, so we will use the same approach as we have done earlier. So fx is equal to 4. Now, if we will find f4, then we will get a 0. Okay, now we will calculate LHL. LHL at x is equal to 4. So LHL means limit x tends to 4 minus fx. limit x tends to 4 minus. Now, who can tell me this? Atif. Atif, can you tell me from 1, 2, and third function while finding the LHL, which function we will use?
First,
First one, LHL. We are finding the LHL of this. Nabil Ahmed, can you tell me if we are finding the LHL, which function we will use?
Second one, sir.
Second one, very good. Please, all of you, please check here. X is less than 4. We have already done these types of question. X is less than 4. LHL means you are approaching from the left side. So that's why you will use the second function here. Okay. So fx means -1. You know how to solve this. Put x is equal to 4 minus h. In the bracket, write when x approaches to 4 minus h. X approaches to 4 minus h approaches to 0. Okay. So write this limit h tends to 0. This remain -1, so you will get a -1 in. Then RHL. RHL at x is equal to 4. So write limit x tends to 4 plus fx. Now the next question is from Josefa. Josefa, for RHL, can you tell me, Josefa, which function we will use for the RHL? Josefa, which function we will choose for the RHL? First function, very good, because the value is greater than 4. So we will use the first function, that is 1 here. So this is 1. Okay, again, same method, put x is equal to 4 plus h. So this will give you h tends to 0. H will always be tends to 0. Okay, this is 1. And the bracket, write when x approaches to 4 plus h approaches to 0. Okay, so this we will get what here? This is equal to 1. Now, LHL at x is equal to 4 is not equal to RHL at x is equal to 4. Hence, limit x tends to 4 fx does not exist. So the function is not continuous, at x is equal to 4. Okay, so this case third is the same. The method in this third case is the same which you have already done in the previous question. Only the difference in this question is, if we will again check the question, in this question we need to check that this function is everywhere continuous or not. So we get this inequality. Always remember, the function will be continuous for greater than 4, will be continuous for less than 4. Okay, where there is a chances that the function is not continuous at that point, at this point. Okay, the reference point. So if you will get a question, then please check the reference point very carefully, because there are the chances that it will not be continuous at this point. Okay, so all of you, please note down this third one. Let me know if it is clear to you. Then we will check the next question. Okay, Nabil, very good. So Atif, Huzefa, Nabil Khan, Noma, please raise your hands if it is done. Okay, Nabil, very good. Nabil Ahmed, Atif, Noma, please raise your hands if it is done. Okay, Nabil, good. Okay, Atif. Noma, is it done? Okay, very, very good, Noma. Now next one. Okay, so I'm going to erase this. Next, the question is discuss the continuity of the function. Okay, so here they didn't give anything else here. They are not asking that check at x is equal to 0 or not. They're just saying that discuss the continuity of the function. So who can tell me, Josefa? Josefa, can you tell me what cases we will consider here? Tell me the case. What will be the case one? As in the previous question, we have formed 3 cases. So Zephyr, can you tell me what are the cases here? No? Atif, can you tell me what are the cases here? What cases we will form?
X will be greater than 0, X will be less than 0, and X will be equal to 0.
Very good. Greater than 0, less than 0, and equal to 0. Very good. So Atif, in these 3 cases, can you tell me where there is a possibility that the function will not be continuous? Atif, can you tell me where there is a possibility that the function will not be continuous? In which case? First, second, or third?
Second,
Second. Okay. Who can tell me? Josefa. Josefa, please tell me in case 1, 2, and 3. In which case there is a possibility that the function will not be continuous? Josefa.
so can you change my answer?
Yes, please.
Yes, the third one. I think.
Third one. Okay. All of you, please check here. I already told you that for greater than 0, you will get a continuous function. Less than 0, continuous. Equal to 0, there will be a chance. Okay. Because for this particular point, the function, please remember that this particular point, at that particular point, there are the chances that the function will not be continuous. Okay. So all of you, please do this question in the same way as we have done the previous one and confirm it. Okay. And if anyone have a doubt, then please let me know. Sorry, Josefa, I've just checked your message. Okay. Next question I will again ask from you. Sorry, Nabil, I've just checked your message. Yes, you were correct. So all of you, please complete this. Write the same language which we have written in the previous questions. Okay, and raise your hands once it is done. Very good, Noma. This is correct. Noma, will you please tell me what the LHL you are getting here? 2. Very, very good. Very good. Yes, that is correct. Nabil, Atif, Zephyr, please confirm your answer. Very good, Atif. That is correct. I'm not taking today your test. Okay, I will take tomorrow. I will take next week, as we need to complete this topic and start the differentiability today. Nabil Ahmed, Huzaifa, Nabil Khan, please confirm once it is done.
So can you show the previous slides for me?
Yes. This one, Atif?
No, sir, even no.
Which one? This?
Yes, sir. Yes, I
Okay.
can go back. I just wanted to confirm something.
Okay, okay. Check.
Yes, sir. Sir.
It's done. Good. So, Nabil, Huzaifa, and Nabil Khan, please confirm once it is done. Okay, Nabil, please check here. First of all, let K be a real number. Real number and K can be greater than 0, less than 0, or equal to 0. So we will divide this into cases. Case 1, for K is greater than 0. Nabil Ahmed, what will be the value of fx?
fx will be x plus 2, sir.
Very good, x plus 2. So we will find fk, that will be k plus 2. Then we will calculate limit x tends to k. X plus 2, this will give you k plus 2. So limit x tends to k, sorry, k fx is equal to fk. Hence, the function is, as a function is continuous for all real number greater than 0. This is clear, Nabil?
Yes, sir.
Okay, very, very good. Can you do the rest, Nabil?
Yes, sir.
Okay, great. So please confirm me once it is done. Huzaifa, is it done? Nabil Khan, is it done, or do I need to do the second and third case also? Okay, Huzaifa, very good. Nabil Khan, is it done?
Yes, sir.
Great, great. So Nabil Ahmed, okay. Please confirm me once this question is complete.
Yes, sir. So second case, for k is less than 0, do we need
Yes.
to expand sine 2x by x, or just we can substitute k, sir?
No, you can use a direct formula. We have a direct formula for this one. Case 2. Okay. So you will write limit x tends to k sine 2x by x. So this will be equal to what? Sine 2k by k. And when you will find the value of fk, that will also be equal to sine 2k by k. Is it clear, Nabil?
Yes, sir. Yes, sir.
Okay, so actually in the first and second case, the function will always be continuous. Okay, the problem arises only in the third case, that equal to. So please let me know once it is done. Nabil, is it done?
Finding limits.
Okay, okay.
Sir, in third case, limit is not continuous, sir. I mean, limit does not exist.
No limit exists. Okay, if you will check here, I'm doing here only. Okay, LHL if you're finding, then LHL means limit x tends to 0 minus sine 2x by x. Then you will put x is equal to 0 minus h. So what you will get here, limit h tends to 0 sine 2 minus h by minus h. So this is equal to limit h tends to 0. What is sine 2 minus h? It will be minus sine theta minus sine 2h by h. Sorry, minus h. Minus will cancel out. So we are getting limit h tends to 0. Sine 2h by h. Now it is 2. We will write here 2. Okay, multiply and divide with 2 because these two should be same. We have discussed this in limits chapter. So sine 2h by 2h. So this will give us 1. So LHL is 2. Okay, Nabil Ahmed.
Sure.
Okay, so what RHL you are
Yes, sir.
getting? Nabil, what is the value of RHL? Nabil, what's the value of RHL?
So RHL also is 2, sir.
It's true. And what's the value of F0? What is F0 here? Okay, so okay, then all of you please note down this as a homework. Okay. So please note down this as homework. Nabil, you have again joined. What's the value of RH? No, sorry. What was the value of F0?
2, sir.
2. Very good. So that means that is continuous at x is equal to 0.
Yes, sir.
Okay, great. So all of you please note down this. This is, you have to do this in homework. Okay, and please do this. This is a very, very good question. Okay. I will check your homework in the next class. So please note down this, raise your hands if it is done so that we can move next.
Okay, sir.
Okay, good. Nabil Khan. Nabil, Atif and Noma, please confirm. Okay, Noma and okay, Nabil. Atif, is it done?
So can you go back?
Yeah, is it done? You have noted this? Okay, I guess Atif, you have done this. So we are moving to next. This is also you have to do in homework. Okay. So first of all, complete the questions which I have given from the slide, then start assignments. Okay. Please note down this. Again, raise your hands once you noted down this so that we can move to the next slide. Okay, Noma, good. Nabil, Atif, is it done? Okay, good. Nabil, is it done?
Yes, sir.
Okay, Nabil Khan, is it done? Nabil Khan, is it done?
Yes, sir. Yes.
Good, good. Determine the value of the constant. This again in homework. Please note down this and raise your hands once it is done. Okay, Nabil, good. Okay, Noma, good. Atif, is it done? Atif, is it done? Okay, I guess you have completed this. Next one.
Can you
Let,
show the last question one more time?
okay. Please note down this.
Done, sir.
Okay, great. Determine the value of the constant m. Okay, so please note down this. This also you need to complete in homework. Okay, all of you, please raise your hands once it is done. And please share your homework. Please do these questions till next week from the continuity. Okay, and do your remaining assignments of differentiation. Okay, Noma, very good. Atif, Nabil. Okay, Nabil, very good. Atif and Nabil Khan, please confirm if it is done. Okay, Nabil, very good. Okay, great. Okay, this is the last question. Please note down this. Okay, please check here. In this question, it is saying that fx is continuous. Okay, they're saying that fx is continuous, find the value of a and b. So here you don't need to prove anything. It is given that it is continuous. So we will write that fx is sorry. In this case, it is given that the function is continuous. So we will not show any case. While finding the value of the variable, we will not show any case. We will do them directly. They are saying fx is continuous, so that means it will be continuous at 3. It will be continuous at 5. So you will find the LHL and RHL for 3 only and 5 only. Okay. As you have done for a single point while finding the value of the variable, you will do in the same way. Okay. So all of you, please raise your hands if it is done. Okay, Nabil, good. Atif and Noma, please confirm. Okay, Noma, very good. Atif,